even more robust, even stronger than they thought they needed. Because they took out the gabions saying, oh, it was fine, the GOG will protect it. And as soon as they took out the gabions and these storms happened, they had problems. The question I've got for you is I picked this out because it's Dawlish Warren. Why have I picked it out because it's Dawlish Warren? Why is that important to you? Why is Dawlish Warren important to you?
Is it a case study?
It's your case study. It's your case study of coastal defences, okay? So, in this lesson today, we're going to be looking at coastal notes, and we're going to have to start, please, actually, just looking through the booklet really, really quickly. Should we talk through this booklet yet or not? I want to talk through this booklet and how you can use it. Let's zoom out a little bit. So this booklet is what you're going to be using to revise from. And just to show you what's really useful, on the front page or in the inside cover, and you can go through this with your booklet and your green pen, you've got a list of all the knowledge organisers, everything that's in here. So if you're thinking, oh, I need to look up coastal landforms and coastal engineering, it will tell you the page number in here. So you've got a list of pages. And then you've got the list for each exam. So exam 1, paper 1, all the topics that are in paper 1 are in here, with all the important things you need to know, and your case studies listed. So when you come to revise, I really recommend that you go through this and you tick off what you completed. So we've already done UK landscapes. We're just about to finish coast today. So you can tick off what you revised and what you know. In this box, you might want to add new forest. You don't need to. You can look to the South Downs National Park for UK landscapes. So I've put a list in here of the case studies that you should have looked at for each of these. And we're going to focus on your paper 1 up till Easter, and then the week after Easter we'll look at ecosystems. So we'll finish paper 1, we'll put the booklets in a folder. And then we'll go on to paper 2. So that's all listed for you with your case studies. And then we'll prepare paper 3. On the back we need to make some changes. We don't study energy for our resource management, we study water. So cross out, we just need to cross out energy really. Cross out energy, and make sure you write water in there.
Yeah, that's
good. Next page, page 4. Should be following in our booklets. Can you cross out this and these pages? You don't need to know that. On paper 2. Paper 3 also can you change our cases. So we did not study coasts and Recolva, so cross that out. We studied rivers and the river Tillingbourne. So cross out coast to Recolva everywhere you see it and change it to river Tillingbourne. In your booklet. Everyone bring their booklets today. You might get a point just for doing that, can't you? Well done. Really organised. And then cross out Margate. We did go to Margate. Where did we go? Guildford. Yay, we had a lovely time. So cross out Margate and put in Guildford. So we did rivers and then we did urban Guildford. And then we did UK challenges. So now that list is correct, you need to revise everything in that list. Okay? Underneath, I put in the 3 exams you'll do. And the number of essays you'll do on each one. Be aware it's only in paper 3 where you do that 12-mark essay. And we did a practice one, didn't we, for your mock. At the bottom in red is things you don't need to revise, but we need to change that as well. So, leave glaciers. We do not revise glaciers. Change water to energy. We do not revise energy. And at the bottom, change, we don't study coastal landscapes. Cross out rivers and put coastal in. And we don't study rural landscapes. So the only thing you cross out is water and change it for energy, and rivers and change it for coasts. Your 2 case studies for your fieldwork are River Tillingbourne, paper 3, and Urban Guildford. So just check that. Do not revise glaciers, energy, coasts, or rural fieldwork. Coast fieldwork or rural fieldwork. Happy with that? So you've got a list of what you do revise and a list of what you don't revise. And then in this booklet, I put a list of what we've got in the booklet basically to revise from. And again, you can put a column down here and tick off what you've completed. So we've already gone through and looked at UK landscapes, geology, lowland landscape and human activity. I'm just ticking that, you can do that later. And we're going on today to look at coasts. And then for homework, you'll do coast exam questions. This is all of this booklet. If you turn over, it's got rivers. This is what we're doing next week. And this is all the things we'll do on rivers to make sure you revise. To help you prepare for the exam, I've put in all the key words the examiner is allowed to use. And I suggest as well you just tick off each one you're confident with. They're not allowed to use any other command words in the exam than these. And then this is probably the most important bit. You've got a knowledge organiser for each of the topics in this booklet. So we've got UK landscapes, coasts that we're going to use for today, and rivers on the back. What I suggest you definitely do to use these is you spend some time, maybe half an hour, you read through and you kind of tick off as you're confident with it, you cover it over and you check it again until you know all the information in your knowledge organiser. When you feel you know all the knowledge in your knowledge organiser, so you do this for coasts, for example, you can then go to your knowledge organiser's quick questions and do them all in one go. You're not at the point now where you want to read the question, go and look for the answer, read the question, go and look for the answer. You want to read all of it and use this to check you understand. To check you understand. So read all of it and then do all the questions. When you're confident you know your knowledge organiser, you can then go on to the exam questions in the booklet. Travis. So for this, you've probably done the coast ones already. When you come on to rivers, learn this really carefully, do your knowledge organiser questions, and then you can find your river questions to the right at the back, and go and do all your river exam questions at the back once you've revised it. That's the best way to use this booklet. For now, we are going to go straight to page 22. And I want you to have a go at annotating the two photographs. Because in the exam, you'll get images and photographs. So turn to page 22. And I want you to annotate the physical processes you see and any human land uses you see. Aiming to get at least 5 notes on each. You can see my booklet now. Those are the answers. I'll go through them with you. So 5 on each, please, annotated with arrows. Physical processes you can see and human use of the landscape, please. Okay, you can do this. Use that pen. You can write around the edge in here.
20.
So you haven't done these topics, have you?
Right, man.
So for you, it's so important that you go and learn these knowledge organisers. So important. Yeah, and when you've learned them, you can do the questions. Don't just kind of give up on it, Ryan, because actually it's really great and you're a good job. You need that knowledge first, don't you?
Mum is sad. She doesn't like me.
Annotating. Go.
Yes, I kind of forgot what it's called.
Groynes, G-R-O-Y-N-E-S.
Yeah.
And mass movement.
Mass.
Shift collapse, isn't it? Mass movement.
Wait. 6, 7, 8, 9.
C'est sur papier, on lit,
Yes. Have you seen the Socrates meme? Have you seen the Socrates? They're in me.
Without talking, you've got 3 more minutes.
No, the computer
Without
works.
talking.
Put a window catch on.
Don't worry about it. Just let me look at the bigger picture you want, as in like, what's this land?
Please put that again. Please. No.
What's this land being used for?
Wait, is this still on 10 or?
Oh my God, John, this is
Again. Boy, miss. Let's see if he started. Oh, yes.
so bad. Like, it's either
top one. Because he's the only one with me.
3, 2, 1. Last minute, absolute silence. No one's talking, or it's a reset. Annotating these images, please.
Yeah, are we doing this page also? Or just
No, just those
Oh,
ones.
yeah.
Okay, let's just go through those answers quickly. Grab your green pen. Going to annotate as much as we can on there. So, this picture here, this is Dawlish Warren. This one here is Dawlish Warren again, so it's your case study, so it's really important you know this one. And let's look at some information you could have included on here. These features here are called groins. They are man-made hard engineering, and they are a sea defence. They're trying to trap the sand. Okay, so we're going to do human uses first. This whole area is a nature reserve. It's a nature reserve. So it's kind of protected. There's boardwalks, there's kind of walkways and paths that people can use. And there's some tourism. Some tourists come to this area to visit. We can see the town in the background. It's built up, and there's a coastal town. There's also tourism. But when we think about the physical geography and what's happening, the key thing is here. We've got an arrow going this way showing longshore drift. Longshore drift is happening. Material is being taken around to form this spit. The feature is a spit. You can see in this photograph. If it joined the land on the other side, it would be a bar. Good, it would be a bar. If it joined an island at the other end, it would be a tombolo. But because it just goes out and then it finishes at the end here, it's a spit. Label the spit. Behind the spit we get what forming? A salt marsh and lagoon. Good. Salt marsh and lagoon.
That's actually so relatable.
The salt marsh is going to get you lots of wildlife and birds out. Are we labelling? I'm just not talking to thin air. We should be writing examples. Okay? And because we know a longshore drift is going that way, we know that, but it's always the same direction as the spit. The spit's going out this way, so that must be our longshore drift. But therefore, the backwash is always going backwards off the beach at 90 degrees. We can put our line in for backwash, because it's under gravity, it's going back off the beach. Which means to go in that direction, the prevailing wind must be coming up the beach this way, and that's creating the sand that's being held here. So add on, prevailing wind is going this way, and then 90-degree angle, we've got our backwash. Prevailing wind up the beach, 90-degree angle, and that forms our longshore drift. sand being trapped by our groins here. And you can label this. This is Dawlish Warren. This is your paste, Dawlish Warren. Having all those labels on, please. Holly, make sure you get the labels on.
I'm spangling.
Next image, let's spot all we can see. This one's interesting. So let's start with human. There is some housing and homes. The land value will have gone down, the tourism will have disappeared, so the economy will have started to tank and go down. Because what's happened here on this coastline, we've got really rapid erosion. We're likely to have strong destructive waves. You put an arrow, then here we've got a diagram of destructive waves. Strong destructive waves that have got a really strong backwash, dragging that material back off the beach. It's removing the beach, and these big waves are coming up, crashing on the beach and removing it away. So the types of erosion are likely to be hydraulic action and abrasion. So hydraulic action, that pounding at the base of the cliff, forcing air in and exploding the cliffs apart, making cracks in them, making them really weak. And then the attrition is, abrasion is when there's sediment in the water being thrown at the cliff and it kind of sandpapers away our cliff. So make sure you've got hydraulic action and abrasion here. Between the tides, between high and low tide, this would happen, and in storm events. Did you get that? Is it clear?
12.
So this cliff line has been broken down with mass movement by basal erosion. The cliff has collapsed because it was a soft rock and clay. So adding all your labels on, please. I'll leave that there for a moment. Okay. Well done. Adding on extras to that to explain it. Add on the extra, please. Making sure it's labelled. Well done, guys. Was that helpful? Have you got much of this yourself? Yeah, it's just being able to recognise it in photographs. So, the information's always there in the photos. I'm sorry it's not easy to see on the board there. I can see what you mean with the light on the board. And by the way, because it's getting so hot in here, because the light's really hard on the board, I told you we're going to have a room change after Easter. We're going to change rooms. We're getting a whole new classroom just for us. So we're going to be on the other side of the corridor. So it'll be Miss Baxter, then Miss Side Road, then we'll be in N116, which means we shouldn't have this problem with our classroom. So we can, yeah, it'll be permanent. That'll be our permanent classroom. I'll put a notice in the window in case you can't hear, but we'll basically come the same way and just keep going. And that'll be our new job for the classroom. Okay. It will stay cooler in there.
What is it?
Also,
Is it so hot?
pardon?
Is it because it's so hot?
It's because people can't see the board in here.
Oh.
It gets really bright. And because, yeah, if it's going to be like a light box, it's going to be so hot. Even in February, like my year 8s were like, literally there was sweat pouring off their little faces. So it gets really hot in the afternoon here. I don't want to have you trying to revise for exams like that. So we are moving through after these. Okay, so we're going to swap rooms, so it's going to be there. There's going to be some. There's going to be a registered room in here, and then it's not used as much. So it's going to be a few history and a few RE lessons. Not very many. The rooms are really used. Okay, so top of the next page, we've got our constructive wave. This lesson, I'm going to talk you through and just get you to make some notes. Put your hand up if I go too fast, or you've got a question, or you want to know something else, please. But the job you're doing is making your revision notes in this booklet. Okay? That's your job, to make your revision notes as neat as possible. So constructive waves, they build up our beach. Like construction, building, builds up our beach. So the wave is low, there's a low wave height, and it pushes material and sand up the beach with a stronger swash pushing it up the beach and a weaker backwash. Has very little energy coming back down the beach. A really, really weak backwash. The strong bit here is our swash going up. So that strong wash pushes materials up our beach. In the exam, you'll likely get a photograph and ask what's happening. Well, what's happening? we're getting a beach formed, that's the key thing. And this often happens in bays. So in a bay, so you've got a kind of curved bay around the edge. And then there's low energy, so material is deposited as waves lose their energy. Material has probably been eroded from these cliffs and is then dropped in this sheltered bay. So we get our coastal deposition features of beaches, spits, bars and tombolos when the sand is dropped. That's as far as I want you to go for now.
Who's, by the way?
So, we've got our constructive wave, and if you want to put an arrow, our constructive wave is creating Dawlish Warren. It's creating the sand and the spit
Do you know what that's
Dawlish
from?
Warren. It's created by constructive waves.
I can say that.
Okay? And if you're confident with constructive waves, constructive, they build. And then what happens is, and you can write this underneath this map, underneath this photo, is that this material which forms beaches, spits, bars, tombolos, is transported, it's moved. Do you know the 4 ways that material is moved along the coast? Solution, what does that mean? It dissolves in the water, good. So solutions 1, traction, rolls along the bed. Nice, well done. Suspension, small particles suspended in our water. Last one, it bounces along the seabed. Saltation. Just check you've got them in your book, please. So materials we move by longitudinal drift. So the 4 ways are solution, dissolve, traction, boulders are rolled, suspension. We need to be writing simple ways. Tiny held in the water and saltation, pebbles that bounce along. Sorry? You're writing it under this photo, in this space.
Is that where you get a ball? Yeah.
Pebbles. So siltation bounces are pebbles. So the biggest bits of sediment get rolled, the boulders get rolled, our tiny pieces can be held in the water, and siltation bounces our small pebbles. But when the water loses its energy, what's it going to do with the sediment it's carrying?
Drop it.
It's going to drop it. It's like when you're tired, you're carrying a big heavy bag and you want to drop it. Okay? Loses its energy, it's going to drop that material. And what are the features that form sand when it drops the material?
They're rounded.
What features, what landforms are created by deposition?
I'm not sure.
It forms, our deposition landforms are beaches, you need to write it down, spits, spars and tombolos. These are all features of deposition. So if you're asked about depositional features in the exam, that's what you're talking about, beaches, spits, spars and tombolos. And then at the bottom of your page, we have got, is everyone finished with that top bit? We have got our destructive wave. Our destructive wave destroys our coastline, destructive. Its wave height is really, really high. All the power is going forward, crashing on the beach, and then dragging the material back off with a really, really strong backwash. We can describe it as scouring. It scours our beach, putting the sand and shingle down the beach. Now we often get destructive waves that look like this in a storm. Because these big waves have to be created by big energy. What's the big energy that creates big waves?
The prevailing wind.
The wind, yeah. If there's a really strong wind in a storm, there's a really strong wind, it's going to create these really big destructive waves. They are powerful. They cause erosion. They erode cliffs and they are dangerous. Are destructive waves are dangerous. If you're on a coastline and you see destructive waves, go nowhere near that water. Okay? They can be really erratic. They will come up and they will pound on the beach and drag everything away with them. So if you got caught, if you decided, because quite often around features like headlands and cliffs where people in the summer, the sun's out, so you think, oh, this is a good idea, I'm going to jump in the water from the top of this cliff or from this stack or something, jump in the water. But if that wave has height, and you can recognise the destructive wave, what it's going to do is you'll jump in, it will drag you out to sea, it will hold you under the water in the waves, it will drown you. Do not go near destructive waves. Yep.
What is the first word to say underneath erosion?
Strong backward.
No, the erosion.
Oh, I've gone through that.
No, no, I'm not.
What does it say?
It says cave. I'm going to go through it. So, these waves, they break down on the beach, they drag the material off, but if you get caught in one, they're going to drag you underneath and roll you around the waves. Be really, really careful. So, destructive waves create landforms of erosion. They create landforms of erosion. They create your caves, arches, stacks and stumps. They create headlands and bays. They create cliffs. Is it possible that a place could have one day constructive waves and then one day destructive waves? It's possible that the waves that take you mainly have constructive waves, so it's always protected. Waves create erosion. Hydraulic action, that's the pounding of the waves, air across
Solution.
Solution.
It's like where the water like dissolves the.
Limestone, it will do like a chemical reaction, dissolve the calcium carbonate, okay, it will dissolve some particles. Well done. We've got hydraulic action and solution. Two more. Abrasion throws sediment at our cliff when the wave, and Molly?
Attrition.
Attrition, which is? So pebbles, they knock each other and round each other off. That's attrition. I've got them in here, let's write them down. So hydraulic action, the force of water pushing air into cracks and breaking open our cliff. It's the same words for rivers, so it's really good to learn these down, get them written down. You can write them above the destructive wave diagram. So 4 types of erosion. Abrasion is like a sandpapering effect. Material is thrown at the cliff and breaks the cliff down. Attrition is our pebbles hitting each other. So sediment breaks down sediment, just hitting each other. And solution, material is dissolved. All of these keywords are the same, transportation and erosion for your rivers work. So it's really good to learn them once and put them for both.
Did she find out?
Right?
turn around. Put that on the street.
You upload it report it. What?
Okay guys, we've got 15 minutes.
What?
Are we happy we've got all that down?
What?
Holly?
What's the
Maybe.
last word on attrition?
Sediment breaks down sediment. So two bits of sediment basically hit each other and break each other down.
Thank you.
You've got 15 minutes. Can you stay for 15 minutes? Because it's really important revision. Yeah? 15 minutes. Okay. Have we got that finished?
You did. Have you written off that?
Yes, Mummy.
Okay, on to our next page. In the exam, they'll talk about concordant and discordant coastlines. Concordant means the waves attract at the same rate of erosion because you've got the layer of rock is at the same angle as the sea, okay? So concordant is the same type of rock. You don't get headlands and bays here. So if it's a hard rock, it will really slowly erode that. The one you're likely to get asked about in the exam is discordant, because discordant forms headlands and bays. So this is a feature of erosion. The landforms are created by erosion. Here, look, the rock is lined up at a 90-degree angle to our sea. A 90-degree angle. So the sea is coming in now, and it's able to erode the softer rock so much more quickly than the harder rock.
Thank you,
Okay.
thank you, thank
So we start getting bays forming here in the softer rock. And what are these going to be? These are going to be headlands sticking out.
That's right, Mummy.
So it erodes the clay quickly and the limestone slowly. Erodes the clay quickly and the limestone slowly. Okay? And it's where the geology alternates between hard and soft rock is a discordant coastline.
Discord.
You're going to add this little diagram here. This is what happens over time. Where our hard rock is, we form a headland,
Just let me
and the
throw.
soft rock forms a bay. Materials deposited, and you get a beach. So headlands form hard rock, and then soft rock gets our beach. You need this diagram, guys. Travis, you can find an image online. You need to find an image of headlands and bays. So it will change from this sort of shaped coastline to really sticking out, protruding headlands and bays. So does the hard rock keep eroding really slowly? Really slowly. But look what happens after a period of time of erosion of the soft rock. The headlands are really exposed. And we call this wave refraction. So the headland is exposed and it can be attacked on all sides by our waves. Does it now speed up?
Yeah.
It now starts to speed up. Write down wave refraction, and our headland is exposed, starts to erode more quickly. What features are going to form out of that headland? Excellent. It's going to start